Okay, this is an instructional video on how to multiply and factor using the area method. This is sometimes called the box method. So I want to give you one example of where this method originates from. One method of multiplying algebraic expressions is to use something called algebra tiles. So if I wanted to find the product of x plus 3 times x plus 3, I could start with a diagram like this, where this length here is x, and then plus 1, 2, 3. Plus, and then this length is x times 1 plus 1, 2, 3. So again, this is x, and then we've got 1, 1, 1, and another x, and 1, 1, 1. If we did x times x, this large square would be x squared. Now remember, each long side is x, and each little side is 1 unit. That makes each rectangle have an area of 1x. Because each little side has a length of 1, each little square has an area of 1 because it's 1 times 1. If I add up all the pieces here, I find that the product of x plus 3 times x plus 3 is x squared plus 1, 2, 3, 4, 5, 6x, because I have 6 rectangles that have an area of x. And then I have 9 little squares with a unit of 1. Okay. So to build on that idea, let's say I wanted to multiply x plus 9 times 5x times 2x minus 5. I'm not going to draw such an elaborate diagram every single time. I'm just going to draw what we sometimes call a box. Sometimes I think it looks like a window. So I'm going to draw my diagram. And I'm going to label this side x. And I'm going to say that this side has a length of 9. I have a plus 9 there. I'm going to say that this side has a length of 2x. And this side has a length of minus 5. Now, if you remember those old multiplication tables from elementary school, the way they worked is you would multiply one number by the other number, and you would look in the middle. And everyone remembered that 12 times 12 was 144 because it was the bottom of the table, and you would stare at it all the time. So this first box, because it's 2x times x, is 2x squared. This one, because it's 2x times 9, becomes 18x. In this box, we have x times minus 5, which is going to be minus 5x. Over here, we've got minus 5 times positive 9 becomes negative 45. So now we write our terms out. And lo and behold, these two are like terms. They're both x's. Now we can't add the x squared because it represents a different amount. It's got a square term. Think about this. We wouldn't add this big square with these little rectangles. They're not the same. So we've got 2x squared plus negative 5 plus 18 is 13x minus 45. Let's do one more multiplication problem before we start factoring. So let's say we wanted to find the product of 3x minus 7 squared. Be a little fancy. Well, the first thing we want to remember is that this is the same as 3x minus 7 times 3x minus 7. We don't want to just square each thing because then we would miss these two squares. Why don't you pause the video and try this problem on your own, and then you can check it. Okay, so now that you've done the problem, we're going to have 3x. Hopefully you put 3x minus 7. Oop, that's a weird 7. And another 3x minus 7. 3x times 3x is 9x squared. And then 3x times minus 7 becomes negative 21x. 3x times negative 7 is still negative 21x. And then negative 7 times negative 7 is a positive 49. When I put my terms together, I would have 9x squared. Well, then I know it's minus 21 and minus 21, and they're like terms because they're both 21x. So I'm going to write minus 42x by putting them together, plus 49. Now let's say we wanted to go backwards. Let's say we wanted to take a product like 2x squared plus 13x minus 45 and rewrite it as the product of two binomials like it is written here. Let's start with something easier. So the directions here might say something like factor the quadratic. And we're going to start with something basic. So we're going to do x squared plus 10x plus 24. And again, we're using the area method. So the first thing I want to do is draw my box. Now remember, this is my product. This is what, this equals, this equals two binomials. So here we go. So first off, I'm going to put x squared in the first box because I know it goes there. And I've got a 24. I'm going to put it in the top right box. So, pretty much I know that whatever I put in these other two boxes have to give me the 10x. So first off, I'm going to think, okay, well, whatever I put here has to multiply to x squared. So that's not so bad because the only choices are x and x. So now I've got this 24, and I got to come up with two numbers that if I add them together, because I'm going to put them here, they have to add to the 10, but they got to multiply to 24. So for example, two numbers that multiply to 24 are 2 and 12. If I put them here, oops, I didn't mean to put the x's. What was that all about? 2 and 12. 2 times 12 is 24. The problem is, when I finish the multiplication table, 2 times x is 2x. X times 12 is 12x. If I add them together, I would get 14x. That's too much. So one thing I like to do is make a little factor tree. And I'll go 1, 24, 2, 12, 3, 8, 4, 6, and that's it because 5 doesn't work. And if I go to 6, I just switch it 6, 4. So because I'm trying to multiply to a positive 24 and add to a positive 10, I don't have to worry about signs too much. And I look, and 4 and 6 add to 10. So I'm going to put 4x, 6x. Now, x times what would give me 6x? 6. X times what would give me 4x? 4. And then to check, 4 times 6 is 24. So these two things represent my factors, x plus 6 and x plus 4. And that's my answer. Now, let's do one that's a little trickier. Let's say we're trying to factor the quadratic x squared. Oops, where'd the square go? Minus, let's do 1x. No, let's do 2x minus 48. Oop, what happened? Ah! The 48 never went in. There it is. 48. Okay. So we're going to start the same way that we did the last one. We just have to be a little careful because now we've got some signs to worry about. I'm going to start with my box. That is terrible looking. And I'm going to start by putting x squared in the bottom left again, because that's the first term. And the only choices to multiply to x squared are x and x. Then I've got negative 48 in the top right box. The problem is there are a lot of things that multiply to 48, and specifically negative 48. To multiply to negative 48, I can have a positive number, and I need a positive number and a negative number. So I'm going to start with negative 1 and positive 48. Some people like to do this without the signs and then just kind of think about them, but I'll write it out for you this time. So it could go the other way. It could be 2, negative 2, and positive 24. Or it could be 2 and negative 24. 3 doesn't go into 48. 4 goes into 48, so we could go negative 4. Oh, wait a minute. Yeah, it does. 4 goes into 48, or 3 goes into 48 16 times. What's wrong with me? So we could do positive 3 and negative 16, positive 12 and negative 4. Those are a lot of choices. 4 and negative 12. 5 definitely doesn't go into 48, but 6 goes into 48 8 times. Oop. And that's it because 7 doesn't go into 48. So which pair adds that all of these pairs multiply to 48? Which pair adds up to our negative 2? Yep, there it is. So we're going to put a 6x and a minus 8x. Well, x times what gives us minus 8x. X times what gives us 6x. And that is going to give us x plus 6 times x minus 8. Be careful with the signs. One trick that someone figured out in my class was that whenever this last number is negative, this box is negative, you're going to have one of each. And then just look over here. See how it was a negative 2? That means the bigger number needs to be negative. If this was a positive 2, it would mean the bigger number needs to be positive so we could add up to a negative, so we could add up to a positive number. Let's do a harder example. Let's factor the quadratic 2x squared Oop, I spelled quadratic wrong. Factor the quadratic 2x squared minus 5x minus 12. All right, again, we want to build the box, but we want to be really careful because this one is not as easy because it doesn't start with a 1x squared. All right. All right. In the first box, lost my pen. We're going to have 2x squared. And in the last box, we're going to have minus 12. The difference between this problem and the ones I did on before is that I can't just come up with numbers that multiply to 12 and add up to 5. I also can't just stick xx here because there's a 2x. So I'm going to hold off on putting anything on the dimensions of my box. What we need to do is 2 times negative 12 is negative 24. And we're going to make the factors again, but instead of doing it with 12, we're going to do it with negative 24. We still need to figure out what will add up to negative 5. So I'm not going to write both signs. I'm going to do 1 and 24, and I'll just know that I have options here with where I can put the sign. 2 and 12, 3 and 8, 4 and 6. So they need to have a difference of 5, and one needs to be positive, one negative. So 3 and 8 have a difference of 5. If I make the 3 negative, negative 3 plus 8 would be positive 5. If I make the 8 negative, negative 8 plus 3 will be 5. So I'm going to make it negative 8x and positive 3x. Now, I always tell people, look for prime numbers here. 2x squared, the only choices for multiplying to 2 are 2 and 1. So it can either be 2x and 1x, or we could switch them. So let's take a look. Then I go to my 3. Well, 2x times something has to give me 3. I can't do that. There is no whole number, that I can do 2 times something and get 3. So I'm going to switch them. I'm going to put the 1x here and the 2x here. So now, 1x times what gives you 3x? 1x times 3. So we'll put a 3 here. Now we have a 2 here, 2x, and this is negative 8x. 2x times what would give us negative 8x? Negative 4. Now let's just double check. Negative 4 times 3 is negative 12. So right away, we've got x minus 4 times 2x plus 3. I hope this video is helpful in working on how to factor using using the area, otherwise known as the box method.